Good afternoon, friends. At least we are now successful. Yeah, now it's my duty to explain to you something on the technologies which are going to be used for the smart city projects. First thing is the Internet of Things, which is now the new developed product, and I will be talk something about the sensors, 5G, and also something about IPv6, which is because these are all required for effective working of the Internet of Things, because that is an attachment to the Internet of Things. See how the data is going to the computer. Normally, human interface is there. See, human people are reading the data, inputting through keyboard or something else, or scanning or like that. So there was a requirement, so that creates error on the data. So data is not error free. That you can see that somebody is the meter reader goes take the readings when he comes to office and enter into the computer. The readings may not be what he has taken from there. That error chance will be there. If we can put a Bluetooth device on the meter, so now almost all the energy meter is electronic, isn't it? If an Bluetooth device is fitted on that meter and some software is there available to interact between the data to the Bluetooth device, the meter reader can go there and just connect his device to the meter. So the data will be transferred directly to the meter. Then the meter, now the energy meter will become an IoT. So IoT is nothing but a sensor, because that is sensing the energy required. The energy meter is the sensor which is sensing the energy supplied to the house. That meter, when connected with a Bluetooth device, that is the network device, plus some software to interact between these two, we will get what is called as an IoT. That will reduce the error, or in the input part, that will reduce the error in the input. That is what. So Internet of Things is a system of physical things embedded with sensors, software, electronics, and connectivity to allow it to perform better by exchanging information to the other connected devices. How it has been developed, the Internet of this thing has first application was for the RFID. See, when there is a stock of so many materials are there, somebody want to take that and writing down and keeping the stock, it was very difficult. So there should be some mechanism to take the available the equipments to the computer to sense that then the development was RFID, radio frequency ID, identification device. That was the first development of RFID. But now the number of IoT devices increased 31% a year over to 8.4 billion in the year 2017, and it is estimated that there will be 30 billion devices by 2020. The global market value of IoT is projected to reach around $7.5 trillion by 2020. So we are now going to see a surge of similar devices for the different applications. Due to the limited address space of IPv4, because that is a 32-bit thing, which allows for 4.3 billion unique addresses, objects in the IoT will have to use the next generation of the Internet protocol IPv6 to scale the extremely large address space required. I will be talking something about the IPv6 later. A complete IoT system integrates 4 distinct components: sensors or devices, is connectivity, data processing, and a user interface. I talked to you about sensors, connectivity, and data processing. It's general, and there should be another interface should also be required. Sometimes the user has to change the settings, or he has to know something, or so many things has to do. So to do that, you have to add a user interface also. There are 4 stages for that one. The sensor devices collect data from the environment. Just like energy meter I told you, there can be pressure, there can be temperature, or any other flow, or proximity. So many things are there that can be sensors for that particular reason. The sensors or devices can be connected to internet through a variety of methods. Even your mobile phone is a IoT device. because it has all these things, sensors are there, it has a location is there, some other acceleration is there, so many things are measuring it in your mobile. So that is connected to the internet through your mobile network. So that is also an IoT device. Data processing could be very simple, such as checking that temperature reading is within the acceptable range, or it should also be complex, such as using computer vision or video to identify objects such as intruders in your house or something like that. So with camera, if the input device is camera and the images are there, then some software should be there to locate what is there is some intruder is coming to the picture or not. The information is made useful to the end user by the user interface. This could be via alert to the user, email, text, notification, etc. For example, a text alert when the temperature is too high in the company's cold storage, something like that. Also, a user might have an interface that allows them to proactively check the system. For example, a user might want to check the video feeds in their house, a phone application or a web browser. If you have a webcam fitted in your house, you can check. When you are outside, you can check somebody has come or any other action also. Now people are using it for monitoring the Aya, which has been checking your child, you are helping your child. So you can check that also, whether she is doing it correctly, your servant is doing it correctly, or your security is doing it properly. That also being checked. This is not a one-way process. Depending on the IoT application, the user may also be able to perform an action and affect the system. So he can change the system values at some time. For example, the user might remotely adjust the temperature in the cold storage via an application in their phone. Sometimes, because see, if you have a AC which is fitted with an IoT device, we can switch on your AC before you reach your home. So you are doing some action before you reaching with your system in your home. And some actions are performed automatically rather than waiting for you to adjust the temperature. The system could do it automatically via predefined rules. And rather than just call you to alert you of an intruder, the IoT system would also automatically notify the relevant authorities. It can make a call or it can send a message, text message. Adding RFID tags to equipment helped track their location was one of the first IoT applications. Out of that 8.4 billion devices, more than half will be consumer products like smart TVs and smart speakers. The next thing, majority of things are smart TVs, which has come to the market at present. The most used enterprise IoT device will be smart electric meters and commercially security cameras. After that, for the industrial use or the commercial use, what has come is the energy meter. That is the most widely used IoT device. Home security systems make it easier to monitor what is going on inside and outside, or to see and talk to visitors. Meanwhile, smart thermostats can help us to heat our homes before we arrive back, and smart light bulbs can make it look like we are home even when we are out. So if you have a smart bulb, you can switch it on and off even if you are not there in the house. So people will think that somebody is there, so they have made the porch light on or something, the bedroom light is on, something like that. Looking beyond the home, sensors can also help to understand how noisy or polluted our environment might be. If you have a pollution monitor, or if you see the number of vehicles, if you want to monitor it there, that is also possible. Autonomous cars and smart cities could change how we build and manage our public spaces. By spreading the vast number of sensors over a town or a city, planners can get better idea of what is really happening in real time. As a result, smart city projects are a key feature of the IoT. As you see, anywhere the application of IoT is required for a good smart city has to develop. So even the car parking also, even if the flow control is there, if you want to know how much cars are passing and where is the traffic jam is there, everywhere these IoT devices are going to be used. Cities already generate large amounts of data from security cameras and environmental sensors, and already contain big infrastructure network like those controlling traffic lights. IoT projects aim to connect these up and add further intelligence to the system. So IoT is the main part which takes care of the smart cities. Because this is where the data source. Instead of manually inputting the data, it is automatically inputting the data to your computers, or what we can say as intelligent systems. Then we'll think of what is a sensor. Sensor is nothing but is an input device which provides an output which with respect to a specific physical quantity. So it is actually a meter, you can say, but instead of it is displaying the data, it is changed to a digital form and sending to your computer to process it further. So it is just like a meter. If you have earlier we have energy meter with the readings only, isn't it? But now you have electronic digital meter, but still it is used as a reading meter. But if you put a Bluetooth device and other things are there, the handheld reading device, if you can have it there, you can go there. And one more advantage is that if the Bluetooth device is there, the meter reader has to go only very near to that. He doesn't go to his then very close to that. So he may not open the gate of the house. He can stand outside the gate itself and he can take the reading. If instead of Bluetooth device, if an internet device is there, he can take the reading from the home itself, from the office itself. So he may not go at all. So that much advantage is putting on by the IoT things. Sensor is an input device which provides an output signal. All are related to the things, because this is same as a temperature. Earlier we have temperature gauge is there, pressure gauge is there. When we say gauge means that is we are showing it as a reading. The other one will call it as a transmitters. Transmitters are there which will transmit the signal, and digital transmitters and analog transmitters are there. But normally when nowadays we calls about only digital transmitters, but that is because we are processing the data in the computer. So digital transmitters are now very common. Analog transmitters are not at all used, because when I was working in a thermal station, we were using as a analog transmitters, which is giving 4 to 20 milliampere standard signal for any range and pressure which we are taking about. But nowadays we are always looking only for the digital. The features of a sensor. One thing is that accuracy. The reading should be accurate. Environmental conditions, where it is going to be operated. The temperature range at which it is going to work. It is going for a military use or industrial use, or it is for a commercial use. All these environmental conditions, we have to look into that when we are selecting a sensor. The range, at what temperature you are going to measure. You are going to measure 100 degrees centigrade or 1000 degrees centigrade. That depends on that. What is the range of this to be measured? Then the calibration. How much time, how often you have to do the calibration of the sensor. Different type of sensors. Sometimes they have to calibrate before every reading. That type of also is there. Something you can calibrate every year or something like that. We can see now your weighing machines are there. That weight has to be calibrated, and machine has to be calibrated every year. That is as per the rule. So there is a separate quality for when we have to do the calibration. The resolution, that is also your requirement. How many digits you have to want to see it there. And the accuracy, it's the same thing. This is the resolution, that is 1.000 if you want reading, or it's only 1, 2, 3, or 1.1, 1.2, 1.3, or 1.1003. So that is how much more resolution you want. That is the thing. Then finally the cost. That is also a part when you are looking into the sensors. Sensors are there for almost everything, we can say. I have just listed some of them only, just to have a feeling of what these sensors are. Temperature sensors are there. They can be thermistors. It's a type of resistor which change the value according to the things. Thermocouples. Thermocouples means two junctions are there of different materials, that when the base is kept at one temperature and the other one changes temperature, there will be a flow of current into that. That is the thermocouples. RTDs, it is similar as thermistors, but this is wires normally it is used, and temperature sensor ICs also is there. Pressure, we have absolute pressure gauges or gauge pressure. Gauge pressure means it is above atmosphere. That is normally what we in the tire pressure which we measure is only gauge pressure. There is, we can also have the absolute pressure that is based on the Vakkom 0. So atmosphere pressure is taken as 1. So it will be added to that one. For the flow, we have turbine type or differential pressure type, because if you put a restriction in the pipe, there will be a pressure difference between the two. If you measure that pressure difference based on the type of restriction you have, is an orifice or something like that, you will can calibrate your meter for showing the flow. So that is different type. Level is there. The level also is a differential pressure, because the standard, if you know, as the water increases, there will be a change in pressure. So it will be, you know what is the difference in pressure at that point. Level differential, ultrasonic radio, because ultrasonic radio will sense it and it will return it back, and that time difference will give you the difference of level. Thermal displacement, etc. Proximity and displacement, photoelectric, capacity, magnetic, because when proximity means what something has come to your nearby, something has come or not, that is what is sensing. It can be a photoelectric, capacity, or magnetic. Photoelectric means some rays are cut or something like that, and capacity means that the capacity measurements has been done. When that comes very close, the capacitor value will be going to increase. So it is that measurement that is going to be measured. Magnetic means if some magnet is coming here, if you have a coil, if it is coming nearby, there will be an induced EMF. So that is sense, that is also taken. Biosensors are there. Image sensors is posted, charge coupled device or CMOS. Charge coupled devices are more accurate. CMOS is not that much accurate. Gas and chemical sensors are there. Acceleration, gyroscope is used. Moisture, humidity, speed, mass, tilt, force, viscosity. There are so many, list is endless. For each and every action there should be a sensor. Then only it can be connected to the system for your, because all the data has to be processed as the thing. Now of the 5th generation mobile network, the 5G. The first phase of 5G specification is in release 15 will be completed by March 2090 to accommodate the early commercial deployment. See, people have started deploying in 5G, but the standards are yet to be completed to accommodate the early commercial deployment. The second phase in the release 16 is due to be completed by March 2020 for submission to the International Telecommunication Union as a candidate for IMT 2020. So worldwide commercial launch is expected in 2020. See, that standards will be ready only by 2020, and it is expected that the final will be only by 2020, the 5G. The ITU IMT 2020 specification demand for speeds up to 20 gigabytes. So 5th generation mobile data has a speed of 20 gigabytes. But this is possible only with a millimeter wave of 50 gigahertz and higher frequency. So existing bandwidth allocation of the spectrum is not sufficient for the 5th generation. So that is why it will take more time, because 3rd and 4th it was same frequency was used. So transition from 3rd to 4th was very easy. But from 4th to 5th the transition is difficult, because the spectrum has to be increased. The millimeter waves also, the 50 gigahertz and higher frequency has to be allocated for this mobile data, mobile network. So that is why it is taking time. Now the government has to allocate the spectrum. The new spectrum has to come. But for interim period, they are using the same spectrum as 4G in the 5G, but the speed available will be not be that much. They won't get the speed of 20 gigabytes per second. However, the speed in these lower frequencies are only slightly higher than the 4G system. Estimated that 15% to 50% faster. Then only that is the only, even if the 5G comes, the existing spectrum, it can be only maximum 50% faster. What will 5G networks mean for me? See, what will the advantage we are going to get with 5G? Faster download and upload speeds. So films now downloading it taking around 15 minutes or something like that, isn't it? 10 minutes, 15 minutes you are taking, but here it will be in seconds. You can download a movie. Smoother streaming of online content, higher quality voice and video calls, more reliable, more mobile connections, greater number of connected IoT devices, more IoT devices can be connected. An expression of advanced technologies including self-driving cars and smart cities. One special advantage of this one is the network slicing. This is the ability to carve out individual slices of spectrum to offer specific devices to the kind of connection they need. For instance, the same cellular tower can offer a lower power, slower connection to a sensor for a connected water meter in your home, while at the same time offering a faster, lower frequency connection to a self-driving cars that navigate in real time. So they can slice the spectrum and they can allocate to one party who is looking more thing, or you can do a small slice to another device, so that they will use only a small sector. So that is very great advantage, because nobody will be going to affect if the other system. Now this is last slide. This is some, I was just talking about what is IPv6, that is also connected here. Without IPv6 we are not able to connect all the IoT devices which are going to be come into the system. IPv6 was developed by the Internet Engineering Task Force IETF to deal with the long anticipated problem IPv4 address exhaustion. IPv6 became a draft standard in December 1998 and became an international standard in 14 July 2017. IPv6 uses 128-bit because IPv4 is only 32-bit. Instead of that, this will be 128-bit address, theoretically allowing 2 into 2 raised to 128 addresses, or approximately 3.4 into 10 raised to 38 addresses. So this have more addresses available for allocating to the new added IPv.